Hello everyone, my name is Mahalakshmi. Now I am going to give a lecture on building blocks of an algorithm. First of all, algorithm represents it is a step-by-step procedure to solve a particular problem. Problem means it refers to a task and it can be solved in form of computer instructions or computer code. The main aim of developing an algorithm is it helps the user to understand how actually the computer instructions are performed to solve a particular task. So it is very important to develop an algorithm in order to understand the computer instructions in form of step-by-step procedure. So in order to develop an algorithm, there are some of the basic building blocks. They are statement, state, control flow and functions. Let us see one by one. First let us see about statement. Statement represents single action in a computer, which means each and every line in the computer code is considered as a statement. In computer code, the statements can be executed in three ways or three actions. They are input data, process data and output data. Input data means here the user is going to give input values to a computer in order to perform a particular task. Next about process data. Process data means here based on the given input the computer will execute the logic. Next about output data. Here the processed data will be displayed as the output. Now consider an example to perform sum of two numbers. Now the input data will contain two input values that are obtained from the user in order to perform a particular task. Okay, so the process data will be the input which are obtained by adding one number with the another number. Output data. Output data means the final added value will be displayed as the output. So this is the concept of statement. Okay, so now let us move on to state. State represents transition from one statement to another statement or one process to another process. For example, the transition from input data to process data and process data to output data is called as state. So now let us move on to control flow. Control flow represents the flow of control in the computer instructions. The flow of control can be represented in three ways. They are sequence, selection and iteration. First let us see about sequence. Sequence means the instructions are executed in sequential order, which means after the execution of first statement, the second statement will be executed. Likewise, after the execution of second statement, the third statement will be executed. For example, consider here is an algorithm to perform sum of two numbers. Step 1 begins with the word start. This represents the algorithm process gets started. Okay, so now in step 2, in order to add two values, it is necessary to get two input values from the user. One value is assigned to the variable A and another value is assigned to the variable B. You can use any variable names. Here I have used as A and B. In step 3, in order to perform addition process, the logic A plus B is used, which means the value stored in the variable A is added with the value stored in the variable B, and the final added value is assigned to the variable C. In step 4, the answer stored in the variable C is displayed as the output. In order to terminate the algorithm, the word stop is used in step 5. Now consider variable A contains the value as 2 and B contains the value as 3 means as per the logic A plus B, the answer 5 will be obtained and it is assigned to the variable C. Now in order to display the answer stored in the variable C, the instructions given in step 4 is followed. Okay, in order to get the output. So this is the concept of sequence. So now let us see another example for sequence. So that is an algorithm to find area and circumference of a circle. Step 1 begins with the word start. In step 2, In order to find the area and circumference of a circle, it is necessary to get the radius value from the user, and the radius value is assigned to the variable r. In step 3, first to calculate the area of a circle, the formula pi r square logic is applied, and the value of pi is directly assigned as 3.14. Now, based on the input radius value, area of the circle is calculated as 3.14 into r, and the final processed data is assigned to the variable area. In step 4, the circumference of the circle is calculated with the logic as 2 pi r. That is, based on the user input value, the circumference of the circle is calculated as 2 into 3.14 into r, and the final processed data is stored or assigned to the variable circumference. Now, the answer stored in the variable area and circumference will be displayed as the output. In order to terminate the algorithm, the word stop is used in the step 6. Now consider the input value of radius r as 2. So the area of the circle is calculated as 3.14 into r. So we can obtain 12.56 as the answer, and now the processed data is assigned to the variable area. Now the circumference of the circle is calculated as 2 into 3.14 into 2. So we get 12.56 as the answer, and now the process data is assigned to the variable circumference. Now the answer stored in the variables area and circumference is displayed as per the instructions given in step 5. So this is the concept of sequence process. That is, after the execution of one process, the next process will be executed. Okay. So now let us see another example for the sequence. That is an example to find average among 5 numbers. Step 1 begins with the word start. In step 2, we need to get 5 input values from the user as per the question. So first input value is assigned to the variable A, and second input value is assigned to the variable B, and third input value is assigned to the variable C, and fourth input value is assigned to the variable D, and final fifth input value is assigned to the variable E. You can use any variable names. Okay. So now to perform average among 5 numbers, we need to add 5 input values, and then we have to divide the final added value by 5. So in order to find sum of 5 numbers, the logic A plus B plus C plus D plus E is used, and then the added value is assigned to the variable sum in step 3. Now to divide the sum value by 5, simply the logic sum by 5 is used. That is, we will get the quotient value, and the answer is assigned to the variable average in step 4. In step 5, answer stored in the variable average is displayed as the output. In order to terminate the algorithm, the word stop is used. Now consider variable A contains the value 1, B contains 2, C contains 3, D contains 4, and E contains 5. So as per the input, sum is calculated as 1 plus 2 plus 3 plus 4 plus 5. And the final value 15 is assigned to the variable sum. Now average is calculated as sum by 5. So we get 15 by 5 as per the logic, and the answer 3 is obtained. So now the process data is assigned to the variable average. So now the answer stored in the variable average is displayed as the output as per the instructions given in step 5. So this is the concept of sequence control flow. That is, without any conditions, simply the logic is executed in sequential order. Okay. So now let us move on to selection. Selection is the process of executing the statements based on conditions, that is based on decisions. If the decision is true, means true block of statements will be executed. If the decision is false, means false block of statements will be executed. Okay, so now let us see example for selection control flow. That is algorithm to check whether the person is eligible to vote. Step 1 begins with the word start. The step presents to start the algorithm. Now, in order to check whether the person is eligible, the age limit should be 18 and above. So the same logic is applied in step 3 as decision. So that is, if the condition age is greater than or equal to 18 means, that is if it is true means, eligible to vote will be displayed as the output. Otherwise, if the condition is false means, not eligible to vote will be displayed as the output in the step 4. So to terminate the algorithm, the word stop is used. So now consider the value of age as 19, and based on the condition given in step 3, based on the input value, the condition is checked as 19 greater than or equal to 18. Okay, so if the condition is true means eligible to vote will be displayed as the output. Okay, so now it is true, so eligible to vote will be displayed. So now consider the value of age as 17, and based on the condition it will check the input value. So 17 greater than or equal to 18. Okay, so now the condition becomes false. So since it becomes false, the instructions given if block will not be executed. So it automatically goes to the else statement in the step 4, that is not eligible to vote will be displayed as the output. So this is the concept of selection process. So now let us see another example for the selection. That is algorithm to check whether the given number is odd or even. Step 1 begins with the word start. In step 2, to check whether the number is odd or even, it is necessary to get the input value from the user and assign the value to the variable num. Now, we all know that if the number is completely divided by 2 means, then the particular number will be the even number. Otherwise, it is odd number. So, to check whether the number is completely divided by 2, we need the remainder value. So, to get the remainder value, modulus operator is used. Okay, so to check whether the number is even, the condition num modulus 2 equal to 0 is used. Suppose if the condition is true means it is even will be displayed as the output. Otherwise, if the condition is false means it is odd is displayed as the output. To terminate the algorithm, the word stop is used. Now consider num as 6. So based on the condition 6 modulus 2 equal to 0 is checked, and now the condition is true, so it is even is displayed as the output. Okay, so now consider num as 3 means based on the condition 3 modulus 2 equal to 0 is checked. So if the condition is true means true block of statements will be executed. Now the condition becomes false because we get the remainder as 1. So it is odd will be displayed as the output. Okay, so now let us see one more example for the selection process. That is algorithm to check whether the number is positive, negative or 0. Step 1 begins with the word start. In step 2, in order to check whether the number is positive, negative or 0, it is important to get the number, that is the input value from the user, and assign the input value to the variable num. Okay, so in step 3, I have used the condition as num greater than 0. This represents the logic to find whether the number is positive. That is, we all know that if the number is greater than 0 means definitely it will be positive. Suppose if the condition is false means it is important to check the logic for negative number. So again in else block I have used another condition as suppose if num is lesser than 0. It indicates negative statement, which means negative number. Okay, suppose if the above two condition gets false means automatically the number will be the 0. So it prints as 0. Okay, so now consider num as 5 means num is a variable that contains the value as 5 means it will check the decision based on the step 3. Okay, so 5 greater than 0. Now the condition becomes true. So positive will be displayed as the output. Suppose if the number is minus 5 means it will check the decision given in the step 3 minus 5 greater than 0. It becomes false. So it goes to else block. That is step 4. It again check the condition, that is minus 5 less than 0. Now the condition is true. So since the condition is true, negative will be displayed as the output. Suppose if num is a variable that contains 0 means it checks the decision given in step 3 0 greater than 0. So it becomes false. So it goes to else block of this if statement and again checks the condition 0 less than 0. It also becomes false. So it goes to the else block of the if statement. Okay, so that is the output 0 will be displayed. So this is the concept of selection. Now let us see one more example for it. Algorithm to find greatest among 3 numbers. Okay, so step 1 begins with the word start. So in order to find greatest among 3 numbers, it is important to get 3 input values from the user. So first value is assigned to the variable A, and second value is assigned to the variable B, and third value is assigned to the variable C. So in order to check whether the first number is greatest means it should compare with the remaining 2 numbers. So same logic is used in step 3. If A is greater than B and C means A is the greatest number. Otherwise, A will be the smallest number among B and C. So in order to check the second number where the second number is greatest means the logic is used in step 4, that is B is greater than 0. If the condition is true means then definitely B will be the greatest number. Okay. Suppose if the above 2 condition gets false means definitely C will be the greatest number. In order to terminate the algorithm, the word stop is used. Now consider A is a variable that contains the value as 2, B is a variable that contains the value as 3, and C is a variable that contains the value as 4 means first it checks the condition given in step 3. 2 greater than 3 and 2 greater than 4. Now it becomes false. Okay. So as per the condition, A will be the smallest number. So it goes to else block of the if statement, that is step 4. So second number is checked with third number. So 3 is greater than 4. Now again the condition becomes false. So finally C is the greatest number will be displayed as the output. Okay. So this is the concept of selection control flow. Okay. So now let us move on to iteration. Move on to iteration. Iteration is a set of statements that are executed again and again based on given condition. Actually, iteration is used to reduce the execution of same process for many times. Now let us see an example to write an algorithm to print n natural numbers based on iteration concept. Step 1 begins with the word start. In step 2, we need to give input value. According to the question, we need to print all n natural numbers. So if the value of n is 10 means we need to print natural numbers up to 10. Or if the value of n is 5 means we need to print natural numbers up to value 5. So input is the n value, which means we need to give stop value and the value is assigned to the variable n. Okay. Now we have represented the stop value. Next, we all know that natural numbers start from the value 1. So it is important to assign or store the start value to a variable. We can use any variable name. Here I am using the starting variable as I. In step 4, we need to give a condition to print first natural number. So the condition is given as starting value lesser than or equal to stop value. Starting value means 1, which is stored in the variable I, and stop value means user given input value. That is, the input value is assigned in the variable n. Now consider n equal to 5. So we are checking the condition, okay, 1 lesser than or equal to 5. That is, we are printing the natural numbers from 1 to the given n value, which is 5. Now the condition is true. If the condition is true means it will go to step 5. That is, the first natural number gets printed. And in order to print the second natural number, third natural number up to the n value, we need to increment the value of I by 1, which means the value of I gets added with the value 1. And in order to repeat the process for n times, we have instructed in step 6 to go to step 4. So the process gets repeated again with the I value as 2. So 2 less than or equal to 5. Now the condition is true, and as per the instructions in step 5, the second natural number gets printed and the value of I gets incremented by 3. So again the process gets repeated for n times. When I becomes 6, now again the condition given in step 4 gets rechecked. That is 6 less than or equal to 5. Now the condition becomes false. So if the condition becomes false means the else block will be executed. That is, in else block, go to step 7 is represented. So in step 7, stop is intimated to terminate the algorithm. Okay. So this is the concept of iteration to print all n natural numbers. Now let us see one more example for iteration. Algorithm to print the word hello for n times. Step 1 begins with the word start. In step 2, we need to give input value to print the word hello up to n times. So here n is the variable, and to that we need to give stop value. In step 3, I have initialized the value 1 to a variable I. This represents that the word hello will be printed for first time with the word hello with the count as 1. So I have assigned the value 1 to a variable I. In step 4, the condition is check I less than n. Consider n contains the value 3. Then based on the condition 1 less than or equal to 3. Now it becomes true. If it is true means it goes to step 5. In step 5, we just simply printed the word hello. Now the word hello gets printed for first time. In order to repeat it for the process again and again up to the n value, the value of I gets incremented by 1. And in order to repeat the process for n times, we instructed to go to step 4 in step 6. So the condition gets repeated with the value of I with 2. So 2 less than or equal to 3. Now the condition becomes true and the steps 5 and 6 gets repeated. And when I becomes 4, now the condition gets false. So it automatically goes to step 7 to terminate the algorithm. Okay. So now let us see one more example for the iteration. That is algorithm to reverse a number. In order to reverse a number, obviously step 1 begins with the word start. In step 2, to reverse a number, it is necessary to get an input value from the user and assign the value to the variable num. In step 3, I have assigned the value 0 to a variable rev, which means initially we are not going to reverse any number. So simply we are giving the value 0 to a variable rev. In step 4, I have mentioned the condition as num greater than 0, which means the number should be greater than 0. Means reversing a number process can be performed. That is, the logic can be performed. Okay. If the condition is true means the last digit of the number is calculated as digit equal to num modulus 10. To get a last digit of a number, simply we need to divide the value of num by 10 and get the remainder value. Now assign the value to the variable digit. Next, in order to reverse the number, we have mention the logic as REV is equal to REV into 10 plus digit. Here 10 represents the place value of a number. After processing, assign the value to the variable REV. Now to repeat the same process till the first digit of a number, we need the quotient value. So the current value can be calculated with the logic as num equal to num slash 10. Slash represents quotient value, modulus represents remainder value. Okay, and in order to repeat the step 4 until the number becomes 0, that is when num equal to 0, the condition gets false and it goes to step 7 to terminate the process. Okay, so consider num contains the value 121. So initially REV is a variable that holds the value 0. So now as per the condition, we are checking 121 greater than 0. It is true. If it is true means digit can be calculated by num modulus 10, which is after dividing 121 by 10, we get the remainder as 1. And the value is assigned to the variable digit. Now reversing can be done with the logic reverse into 10 plus digit. So now we get the reverse value as 1. Now in order to find the current num value, we need to divide the num value by 10. That is, we need the quotient value. So the quotient will be 12. So this is considered as a current num value, and with the value further more process can be repeated. So in step 2, we are rechecking the condition with the num value as 12. So 12 greater than 0, it becomes true and the digit can be calculated with the logic and the answer will be 2. And similarly, reversing can be done with the logic as reverse into 10 plus 2, which means 2 is the digit value, 1 is the previous reverse value. Okay, so reverse will be 12 in step 2. So in order to get the current num value, num is divided by 10 and the quotient value will be 1. So again step 3, which means the furthermore process is repeated with the num value as 1. In this step we get the digit value as 1 and reverse as 121. Now the number is reverse and the numbers will be 0. So again the condition will be rechecked. Now 0 greater than 0. Now the condition becomes false. So automatically the algorithm gets terminated. Okay. So now let us move on to functions. Function is a block of statements that are executed during the function call. Here, in order to perform functions, the concept is divided into 2 parts, that is main function and subfunction. Okay, here is an algorithm to perform addition of 2 numbers using function. Okay, so main function actually contains the concept of the process with this subfunction, that is user-defined function. When the subfunction is called, the block of user-defined statements in this subfunction gets executed. In the main function, I have simply represented the start of the actual process in step 1. And then I have called this subfunction with the name as add with no arguments. That is, we are not going to pass any value from the main function to the subfunction. Simply the subfunction is called with the name as add. Okay. So now the subfunction gets executing. Okay. So which is represented as function start in the step 1 of subfunction add. In step 2, the user is giving 2 input value to perform addition process. Okay. So the value of one number is assigned to the variable A and another number is assigned to the variable B. In step 3, we are processing the input value based on the logic A plus B and the value is assigned to the variable C. In step 4, the output value is a variable. Output value in the variable C gets printed in subfunction. Since we are not going to pass any value to the main function, we are just simply printing the value of C in the subfunction itself. Okay, and the subfunction process return the main function with no return type, and then the whole program gets terminated as stop, which is given in the step 3 of the main function. Okay, So now let us see one more example for the function using recursion concept. Okay, actually recursion is a process which is used to repeat the function again and again during the function call until the base function is satisfied. Okay, here is an example to find factorial of a number using recursion. Step 1 begins with the word start. Okay, in step 2 we need to get input value to find the factorial. Okay, and the input value is assigned to the variable m. We all know that basic logic to find the factorial is if the value is greater than, negative number means we can't able to find the factorial for a particular number. That is, we can't able to find the factorial for the negative numbers. And if the value of 0 means the output will be 1. So the same logic is mentioned in the main function. Okay, simply we are getting the value and assigning the value to the variable n, and if n is lesser than 0, which means negative number means, then automatically factorial does not exist for negative numbers will be printed. If the n contains 0 means 0 equal to 0. If the condition is true means the output will be automatically displayed as factorial of 0 is 1. If n contains 5 like that means it will go to else block. That is, step 3 and step 4 will be false and it goes to step 5. In step 5 we are calling the subfunction with the name as fact of n. That is, we are passing the value of 5 in the variable n to the subfunction. Okay, so now automatically the user defined function starts executing, and the value given in the main function is passed to the subfunction. Okay, so n is also a variable that contains the value 5. Okay, in step 3 of the user defined function we have mentioned one condition. That is, if n equal to 1 means it return the value 1 to the main function. Okay, we all know that to find the factorial, that is, if we want to find the factorial value for 5 means we need to calculate from 1 into 2 into 3 into 4 into 5, so that it is considered as a stored value. So that purpose only here I have mentioned the logic. Okay, if n equal to 1 means then it will return the value of 1 to the main function. Otherwise, now n is considered as 5 means it becomes false. So it goes to step 4. In step 4, here we are recursively calling the same function for n times. That is, n into fact of n minus 1. Until the condition becomes false, the same function is recursively called. Okay, so consider n contains that is 5 means the 5 is passed to the subfunction. So in step 3 of the user defined function, n equal to 1, which means 5 equal to 1, it becomes false. So it goes to step 4. In step 4 it will return n into fact of n minus 1, which means 5 into fact of n minus 1 means 4. Okay, so here fact is also a function. It is called again with the current value as 4. So again it checks the condition 4 equal to 1, it becomes false. So it goes to the step 4. So already previous value 5 will be there, so 5 into now the current value as n, which contains 4 into fact of 3, n minus 1 3. So again fact of value fact function is called with the value 3 and the process repeated. Okay, when the fact of 1 is called, it checks the condition 1 equal to 1. Now the condition is true and it returns 1. So final value will be 120 and the value is returned to the main function, and 120 will be displayed in step 6 of the main function. And in step 7, in order to terminate the algorithm, stop is used. So thank you.